In example 7, we're going to begin again by calculating the discriminant of this. A is 4, B is negative 12, and C is 9. We're going to be plugging these into the formula for the discriminant, which is b squared minus 4ac. So we have negative 12 squared minus 4 times 9, which all comes out to give us 0. So when we calculate the discriminant and we get 0, now 0 is not positive, but 0 is a perfect square. We can factor if the discriminant comes out to be 0. Not only can we factor, but in the table we saw earlier about the discriminant, it told us that we only get one repeated solution. So we're not expecting to have two answers here. We're only expecting to have one answer. And so now let's go find it. So because I know I can factor, I'm going to set up 4x squared minus 12x plus 9. We're going to set up the different ways we can factor this. Keep in mind that in this example here, a is not 1, so it's not sufficient for us to just look for numbers that multiply to 9 and add up to negative 12. We're going to have to be a little bit more creative than that. Because a is not equal to 1, we will need to play that guessing game to see how we can factor this. So starting off, I need things that would multiply to give me 4x squared. I could multiply to get 4x squared by doing 2x and 2x, or I could multiply to get 4x squared by doing a 4x and an x. So it could look like either one of those. We also need things, so the different possible combinations here is either going to be a 2x and a 2x or a 4x and an x. We'll start checking them in a second though. I'm going to erase this for now because the actual factorization will be with the 2x's, and we'll see why in a second. To fill in the other blanks, the other side of those parentheses, we need numbers that multiply to a positive 9. So the numbers that multiply to a positive 9, it could be a positive 3 and a positive 3. It could be a negative 3 and a negative 3. It could be a positive 9 and a positive 1. And I don't need to switch those because those would be the same thing. So what I'm saying is typically like we always switch and look at it like this. But these two things are exactly the same thing. They're just written in a different order, and that does not matter because multiplication is commutative. It doesn't matter what order you do it in. So now I'm just going to be checking the middle term to see which one of these factorizations gives me a middle term of negative 12x. So 2x times 3 gives me a 6x. 3 times 2x gives me another 6x, which gives me a positive 12x, which is not quite what we want because we do want to get terms that come together to give us a negative 12x. 2x times negative 3 is a negative 6x, and then negative 3 times 2x is a negative 6x. And that does give me a negative 12x. So now I know the correct factorization. I don't even have to check the other ones. We can return to the problem. I'll just rewrite the original problem down here. And then under that, I will just put the factorization, which is 2x minus 3 times 2x minus 3. Now that we have that factored, we can set the factors equal to 0. And I don't have to set both factors equal to 0 because they're the same factor. We're going to get the same answer. We'll add 3 to both sides to get 2x is equal to 3, and then I will divide both sides by 2 to get that x is equal to 3 over 2. And that is our one repeated solution. There's no need to write it twice. So we have that solution there. Notice that when we factored this quadratic, the factors were the same. It was 2x minus 3 multiplied by 2x minus 3. That is a special type of quadratic expression. We've already seen one special type of quadratic expressions. That was a difference of squares. Now we are looking at a perfect square trinomial. Here is the general form for a perfect square trinomial, and I want to show how example 7 fits that, and also how we could identify a perfect square trinomial. So example 7 was 4x squared minus 12x plus 9. That's just the quadratic part. I don't need the equation part. So the things that you're looking for in a perfect square trinomial is you're looking for the first term to be something squared. Well, we've already seen that 4x squared is 2x squared. So in this case, our a is 2x. What's being squared in that first term? And you're also looking for the last term to be something squared, the constant term to be something squared. And it is. In our case, our 9 is a 3 squared. So our b is 3. And then once you identify, hey, the first term is something squared, the last term is something squared, you look at those two somethings, which would be your a and your b, and you say, well, what is 2ab? Well, in our case, that would have been 2 times a, which is 2x, times b, which is 3, which would give us a 12x. And notice that 12x is exactly what we have in the middle term right there, a minus 12x. So we had the form a squared minus 2ab plus b squared. And that will always factor into a minus b multiplied by a minus b, a perfect square trinomial. Generally speaking, this will factor into I'm going to put plus or minus b, a plus or minus b, which keep in mind we could also write as a plus or minus b squared, since we're multiplying the same thing there. This looks strange. Squared. So I want to talk about why we have that plus or minus there, and let's look at that by jumping into example 8. I'm going to start example 8 by getting 0 on one side of the equation by adding 30x to both sides of the equation. That gives me 9x squared plus 30x plus 25 is equal to 0. I'm not going to calculate the discriminant of this. I encourage you all to calculate it. You should calculate b squared minus 4ac is equal to 0. That will again tell you that you're looking for a repeated solution. And it also tells you that you have a perfect square trinomial. Because the only way you're going to have a repeated solution is if you had a perfect square trinomial, the same factor being squared. Let's see if we can identify this as a perfect square trinomial. Looking at the first term, that 9x squared, that is something squared. That is 3x squared. Looking at the last term, the 25, that is also something squared. That is 5 squared. So this identifies a as 3x and b as 5. Now we need to go check, well, what is 2ab? Well, that would be 2 times 3x times 5, which conveniently for us is a 30x, which is exactly what we have in the middle. So because these things checked out, this is in fact a perfect square trinomial. So how this factors, I'm just going to rewrite the problem here so we can talk about how this factors now. It factors into, because this quadratic, this middle term here, was a positive 30x, we're going to choose the ones that have the plus signs. That's what this means. So this plus or minus means that if your middle term was positive, when you factor, you'll have plus signs. If your middle term was negative, like we had up here with the negative 12x, we had a negative 12x there, and we chose minus. We had to use, not even we chose, we had to use minus signs when we factored it. Here, our middle term is a positive 30x, and so we will be using plus signs when we factor it. And it still factors into the same form, though. A plus B, A plus B. A is 3x, and B is 5. So we have 3x plus 5, 3x plus 5. And now I'll set both of my factors equal to 0. Well, no, I won't. I'm not going to write it twice because we're going to get the same answer. They're the exact same factor. I'll subtract 5 from both sides of the equation to give me 3x is equal to negative 5. And then I'll divide both sides of the equation by 3 to see that x is equal to a negative 5 over 3. And that is our only solution there.